Alright. What timer to keep track of us? Alright, so we are in our, this one's the send terminal and the receive pi. Yeah. So first thing we gotta do for a wireless packet is receive.c is make sure that this is WLAN or WLAN and and not save it. Okay, and this is our MAC address for this pi, since this is the receiving pi, and let's change this back. Cool. And the same thing for this pi, and this will have the MAC address of the receiving pi right there. WLAN 0, and I'm going to go ahead and just set this back to default as well. Alright, so now we just gcc send.c to compile it, -o send, and then sudo./send. But before we do that, let's compile this one. Receive.c -o. Okay, and then sudo./ sorry, I have dyslexia. Okay, so have that going first, and before I forget, I like this command because it stops it. So we should get 5 from this. 1 million microseconds equals 1 second. So 5 packets is the maximum we can send, and it sent 5. And 1, 2, 3, 4, 5. We got 5. Cool. So now for a packet sending through Ethernet. First thing, just close out the terminal. Show you my little Pi setup right here. And just gotta hook them up to the Ethernet. Make sure they got green light. And hope I remember the Ethernet IP addresses that. Green light, awesome. Okay. And then we just go back in the terminal, and then same thing pretty much. Okay. There we go. All of them but. Cool. Alright. So sudo send.c or nano send.c. and then we just gotta change this to ether to get ether connection. Alright, that works. And then just compile it. Alright. Same thing with this one, they have to match. Okay. Alright. So, again, 1, 2, 3, 4, 5, done. Alright. And then we 1, 2, 3, 4, 5. Alright. Now to discuss what the results were. So I did 3 trials of each, 3 wired, 3 wireless, 3 wired with other devices using the internet, and 3 wireless using 3 devices over the internet. And overall, the margins were measurable, but not noticeable. Like there wasn't a 100, 200, 300 packet difference between the two, and yeah, like between the wireless and the wired and the multiple devices versus the bare minimum for this project, the 2 Pis and this laptop, there wasn't really a noticeable there wasn't more packets coming in, and they weren't coming in faster. Let's just say that. So I did for my test, for all of them, I did 1,000 microseconds, and I did a 5-second runtime. So the maximum amount of packets we should be able to get is 5,000. Right, and I chose this number because in the terminal, if you do more, I'll show you in step 4. I'm sure you probably know this too. It kind of the top of the list like deletes itself to make room for more incoming data. So I really didn't get an accurate picture when having more than 1,000. But overall, the wireless was actually faster. I do want to start out and say that. Wireless was faster than wired connections overall. And so was the wired under, or the wireless under multiple devices using the internet, the multi-person thing, multiple people, yeah. I kind of just simulated that. I turned on my PS4, had some streaming device, streaming on my phone and my iPad, and yeah. And again, they weren't measurable from like the or they were measurable from the no devices versus multiple devices, but it wasn't significant, and the wired was still faster. So yeah, I explained it that well. You know, I put the average, and overall, I only lost 2 packets during the 6 test, and that was under the wired multiple devices test, and that only happened once. And I kind of theorized about it in my little paper there. You know, it could be the PI just being so close to the router, and or it could be just an example of not enough, like, a wrong one, just not enough trial data, you know, like maybe if I did 100 tests, the data would have widened from each other, from the wireless or the wired, or narrowed, you know. It was already pretty narrow, so I doubt that, but like, yeah. So before I explain what happened with step 4, let's just show you the MAC address. If config etho. So I changed the MAC address on my SynPy, just 112233445568. So yeah, I just did that on my SynPy. It's pretty easy, you know. Use the article. Yeah, I have it right there. This command line right here. And yeah, okay. So step 4. Sudo /send1. I made a little separate file for this. Timeout 5. Yeah, make sure to do that. Okay. So I got the send portion to work just fine, as you're about to see. It numbers all the packets, 1 through about 60,000. This is 1 microsecond. So the maximum packets I should be able to receive is 5 million under a 5-second constraint. But as you can see, it's a lot lower. I couldn't get the receiving part to end. What was happening was it was no matter like what the microsecond was and how long I ran it, you know, like even if I was only supposed to get 1,000 packets, it would still be showing me like packet 17773 was missing from the receiving end, and it just kept repeating that value over and over and not really giving me the real values. So solution 2 was to do something like this. Output2.txt. So I had it redirected to a file, but I kind of figured that you would want it in, you know, 1 microsecond, 10 microseconds, 100 microseconds, you know, somewhere along that range where we could get like actual data from it. But this was hard to retrieve too, because nano output2.txt. So I couldn't really copy all this. It, you know, not really. Even curl m6, you know. And theory was I put it in an Excel sheet, sort it from numerical order, you know, packet like 1 to 64,000 or whatever we got, but 64095. I guess we could see the, yeah, so it looks like we lost about 600 packets from that, but it's just, I can't go through and see which ones were missing. There's just too many of them. too many copy, too many paste. Anyways, I was going to do an Excel spreadsheet and numerical order, and then see if I could get a command where if it continues the sequence even without the number being there, therefore knowing which ones were missing. But I couldn't do that. Yeah.